So, at the beginning, there was one framework, there was one stack, and there was one way of using them. We all try to follow the golden path. We try to keep things simple. We try not to repeat ourselves. And we wrote skinny controllers and fat models. You know, we were young and naive, and life was good. Programming, thanks to Rails, was a joy. Soon, the framework became a huge success. More and more Rails projects were started, and more people came to the community, which was fantastic. At the same time, our applications grew in size and in complexity. And in some cases, they became increasingly more difficult to maintain. To remedy this, people in the community started to propose alternatives to the main stack and to the golden path. Today, we still have one framework, but now we have many libraries, many patterns, and several ways. We all want to write better code and more maintainable apps, but now we have too many choices to choose from. Should we deviate from the Rails way to do object-oriented programming right? What are the benefits of using that pattern or that technique that I've just read about? And more important, what are the pitfalls? The purpose of this talk is not answering these questions, because basically there is not a single answer. My purpose in this talk is to explore together with you these 6 ideas, which are only a few concepts of software design that we could use to answer the previous questions and to evaluate the convenience of applying any particular technique or pattern to our code base. I only have 30 minutes for this, so let's better get started. We will start with the basics, cohesion and coupling. You know, even though these are 2 old and very well-known concepts in software development, we programmers keep writing tightly coupled code and low cohesive code every day. So I think it's good to revisit these 2 concepts. Low cohesion is a typical characteristic of big active record models, of fat models, you know. Let's take, for instance, this gigantic article model. Don't worry if you cannot see the code, because that's the point. In this application, users can add tags to their articles, you know. They can tag articles. To implement this functionality, in the article model, we have a couple of has-many declarations at the top of the file, and a scope to fetch all the articles that have a given tag. We have also a virtual attribute to conveniently convert the tags from and to a string of tag names separated by commas. And finally, at the bottom of the file, we have the private method which takes care of that conversion. You know, this example shows one of the problems of low cohesion, which is the vertical distance. We have logic, which is completely related, scattered across this large file. To maintain the tagging functionality, we will have to jump up and down several times. And, you know, anyway, it will be hard for us to have a mental picture of all the logic involved in this functionality. Martin Fowler gives us a very useful rule of thumb to keep our code highly cohesive. Put together what changes together. In our example, we expect all the code related to managing tags to change probably at the same time whenever the functionality of tagging changes in our application. So one refactoring that we could do, and this is just one solution, there are many, this one would be idiomatic in Rails, would be to extract all the tagging code to a Rails concern. That way, this would be the concern, that way we had put together everything that will probably change together. We keep our code highly cohesive and easier to maintain. Let's talk now about coupling. Coupling is a concept sort of complementary of cohesion. If cohesion is about putting together what changes together, loose coupling is about keeping separated and independent whatever is not supposed to change together. This photo explains what a tightly coupled system is. You know, each shoe is supposed to be able to change its position independently of the other shoe. Legs are the component of the system that will coordinate them, right? You know, the pitfalls of such an unnecessary coupling are evident, right? So, in the context of Rails, a popular example of coupling is active record base itself. Basically, active record implements a very specific persistent strategy that every model inherits. That causes that the domain logic of each model and the way it is persisted are tightly coupled. If tomorrow I need to change the persistent strategy, you know, if I need to move from MySQL to Mongo to Redis or to anything else, I will probably have to change the way the business logic is implemented as well. But I'll go back to this example later. I will stop now. Let's move to the second topic of the talk. Just a moment. The solid principles. As I suppose most of you know, solid is an acronym that stands for these basic principles of object-oriented design that were identified by Robert Martin, Uncle Bob, around 12 years ago. These principles are quite often referenced by those who are trying to apply techniques from the object-oriented world to Rails. And by the way, this guy is not Uncle Bob, it's not Robert Martin. This guy is Charlton Heston playing Moses. We don't have time to go through each of the solid commandments. I'll just share with you a couple of ideas about the most popular of them when it comes to criticize Rails. The famous single responsibility principle. I guess it's not necessary to explain what this principle is about, not only because it's very popular, but also because the definition is in the name itself. It's self-explanatory, isn't it? This is about keeping our classes with one only responsibility. By reading its name, we not only understand the meaning of the principle, but also we instantly know that our code violates it big time. Some questions arise later, you know. What is exactly one responsibility? How can I identify responsibilities? Robert Martin, Uncle Bob, defines a responsibility as a reason to change. And while I'm not sure this definition responds to any of my previous questions, it indicates that, again, this is about things that change. There is something very curious I found while researching this topic for this talk. Robert Martin links from his own website to this document as kind of the canonical reference regarding the SRP, the single responsibility principle. I believe this is an article, you know, this article is a chapter of this book of him. These are 3 different editions, but I think it's the same book. The thing is that in the website of Object Mentor, which is Uncle Bob's company, there is a link to something that looks like a different version of the same article. Besides obvious differences like the number of the chapter and the picture, the contents of the article seems very similar, except for one thing that I found insightful. To illustrate the principle, Uncle Bob shows an example of a Java interface where he identifies 2 different responsibilities. And then he asks himself, should these 2 responsibilities be separated? The answer in one of the versions of the article is, almost certainly they should, which is fair enough. You know, this is an article about the SRP, so it makes sense to show an example that violates the principle. The thing is that in the other version of the article, the very same example is shown, and the very same question is asked. Should these 2 responsibilities be separated? But now, the answer is slightly different. That depends on how the application is changing. What? I don't know you, but I think this shift from almost certainly to it depends is amazing. You know, it transformed the principle from something dogmatic into something that we can use. Later, in the same version of the the article, he states, if the application is not changing in ways that cause the two responsibilities to change at different times, then there is no need to separate them. Indeed, separating them would smell of needless complexity. And he adds, finally, an axis of change is only an axis of change if the changes actually occur. By the way, these two paragraphs don't exist in the other version of the article. This brings us back to the example of active record base and the problem of coupling persistence with domain logic. Persistence and other responsibilities in the same object are the classic example of violation of the single responsibility principle. Even the article I just referred to, the article by Uncle Bob, includes an example about persistence. Nevertheless, let me try to challenge this assumption. How often do we expect the persistent strategy of our application to change? How often do we expect to switch from MySQL to Mongo or to Redis or an external service? If this is something that we expect to happen only rarely, I wonder if prematurely separating persistence from other responsibilities wouldn't be a smell of needless complexity. All right. I don't know if you know practice in Ruby, but it's one of the great resources that I discovered while researching for this talk. Totally recommend it. I found one of the articles in there particularly insightful. It's titled Responsibility-Centric versus Data-Centric Design. In it, its author, Gregory Mock, discusses about two big design styles people in the object-oriented world have been arguing about since long ago. On one side, maybe the more classic of the two approaches is the data-centric or the domain-driven approach. In this style, modeling happens around data. The classes that we have correspond to entities of the real world. We have classes like project, blog, task, order. All these concepts, which every user of our application understands, become the protagonist of our domain model, and the behaviors of the application will be attached to these entities, to these classes. Low cohesion or single responsibility principle violations, which is the same thing, are a natural consequence of this style. Since behaviors are grouped around the entities that are related to them, chances are that classes will have more than one responsibility, more than one behavior. I'm sure you are familiar with this style, as it is the one that Rails and Active Record follows. Finally, there's a very good book elaborating on this style, which is Domain-Driven Design. On the other side, we have the responsibility-centric approach. In this style, modeling happens around behavior. That means that the main classes of our domain will have names like post indexer, order processor, project database mapper. These are concepts that don't correspond to entities of the real world. And users of our application don't know anything about any of these. These are just artifacts that we create and that are only part of the solution. In this approach, data is treated as data. We will probably model it using objects, but those will be basically dummy objects, which only purpose will be to provide controlled access to the data. The single responsibility principle is, in general, very easy to satisfy here, as each object in our system represents one single behavior, one single responsibility. On the other side, this style leads to what it's called anemic model, in which the data and the logic that operates over that data are in different places, are in different objects, which might be considered a problem of encapsulation or low cohesion, even. This style have gained popularity, in particular in the Java world, and this book explains it brilliantly. And just in case you didn't notice, this is not the idiomatic way of doing things in Rails. I find the differentiation of styles useful for two reasons. The first is to acknowledge that there are different design styles and that each one of them has its own trade-offs, which are intrinsic to the style itself. And the second reason is to acknowledge that Rails follows one of the styles and not the other. So if you want to try the responsibility-centric approach, which is something very legitimate, you should probably not use Rails for that, or at least not active record. Otherwise, you might end up with a strange hybrid style, hard to understand and maybe hard to be consistent with. This is the fourth of 6. Okay. When it comes to talk about ceremony, it's always, there's nothing like showing a snippet of Java code and compare it with its equivalent in Ruby, right? That illustrates the difference between ceremony and essence. Ceremony is all the irrelevant detail that we have in the Java version. Unfortunately, ceremony is not something that one avoids just by switching to Ruby. There is plenty of room to be ceremonial in Ruby. For instance, this is perfectly valid Ruby code, but its intent is only obvious in this version. This snippet looks simple enough, but this other snippet captures better the essence of what we are trying to achieve. Even in a case like this is perfectly nice code. Well, there's a bit of ceremony, if you want. A very good resource I found about ceremony and essence is a presentation and a blog post by Stuart Holloway titled Ending Legacy Code in Our Lifetime. In these two resources, the author characterized legacy as the degree to which code fails to capture intent, fails to communicate intent, and captures irrelevant detail. He calls essence to that code that captures and communicates intent, and ceremony to that code that captures irrelevant detail. Irrelevant from the point of view of the developer, of course. So this is about how effectively our code communicates its intent and nothing else. It's about maximizing the signal versus noise ratio of our code. And I think this is a very interesting trade-off because, very often, trying to make our code more flexible or introducing that new abstraction or that new pattern, might have a cost in terms of ceremony that we should weigh properly to make sure it is worth. The cost of indirection has been a topic of discussion since the very beginnings of computing. Back then, there were heated debates about the convenience of adding new layers of abstraction, new layers of indirection, as each one of them implied high costs in terms of performance. Happily, today, things are completely different. Over the last 50 years, CPU speeds and memory sizes had increased so dramatically that the cost of adding new indirection layers are, compared to them, almost negligible. That's why we have languages like Ruby to start with. But what about our brains? Cognitive psychology studies, among many other things, what are the limits of our capacity to process information. And it turns out that we are unable to hold more than 7 chunks of information in our working memory at the same time. Apparently, the exact number depends, of course, on the person and on the complexity of the data we are dealing with. But in general, we can say that the length of our stack buffer is not larger than 7. That means that when we come across long stack traces, where we have to jump by more than a few levels of indirection to understand what's going on, what probably happens in our brain is a stack overflow, probably. So every time that we add a new indirection layer, a new level of indirection, for instance, when we extract some code to a service object or to a concern, as we did in the first example, we have to be aware that we are incurring in a cost. We might be increasing the cognitive effort to debug our code. The benefits may very well justify the cost, but it's important to be aware of the costs, I think. And I have a couple of quotes about this. The first one is a tweet by Kent Beck, who that day was in Zen mode. First, you learn the values of abstraction, then you learn the cost of abstraction, and then you are ready to engineer. And I have another quote in the absolutely opposite style by Seth So, who that day was in pissed off mode as usual. I won't read this one out loud. But just in case you didn't have time. So, in this talk so far, we've seen only a few aspects of software design that we can apply to our code. The problem is that, as we've seen, often this principle conflict with each other, and we'll have to choose which one we want to prioritize in each case. There will always be room for opinion, and there will always be room for debate, for discussion in the community. Everyone agrees that Rails deviates from the object-oriented dogma in many ways. The question is whether that's a good thing or not. Giles Bouquet have recently published an ebook where he discusses this particular topic. As he explains, Rails makes good user experience its primary goal, where user means the application developer. The user experience of us, of the developers. Focusing on that is what makes Rails different, in my opinion at least. With that in mind, it's easy to see why some of the aspects we've seen today, like minimizing ceremony or minimizing unnecessary indirection, are imperative in Rails, while others, like the solid principles or the rest of the object-oriented design dogma, become secondary actors or even things to avoid if they put themselves on the way of an easy-to-use API. Yeah. At the beginning, there was one way of doing things. Today, we have many to choose from. And I hope that some of the ideas that we've seen in this talk will help you making those choices. Thank you.